Hello friends, welcome to my channel, myself Parag Jambulkar. In this video, we will discuss about parallel computing, need of parallel computing, its limitations and applications of parallel computing. Need and limitations of parallel computing makes scope of parallel computing. So let's get started. First, we will discuss about what is parallel computing. So we have a processor and we give some tasks to the processor. Assume we have a single processor. So when we give tasks to processor, so it will execute one by one. So first task will get completed, then another one, then this third one, then fourth, and then next task. If one finish the task earlier, so the processor should have higher speed. So why should not we increase the speed of processor so that the task will take less time? But this processor has some limitations. For example, if we increase the clock speed of processor, if we increase the frequency of processor, it emits heat. So our processor has some limitation. That's why we cannot increase the speed of processor. So definitely, when we are completing the task sequentially, so we will complete this task, then we will complete another task, then we will complete third task. So it will take so much time. So suppose one task is taking 1 unit of time, so n task will take n unit of time. Instead of doing this task sequentially, we can have multiple processor and we'll give first task to the first processor, second task to the second processor, third task to the third processor. So suppose one task take 1 unit of time. So all the tasks they are executing simultaneously. So all our n tasks will get completed in 1 unit time only. So when we are executing tasks sequentially, we require n unit time, while when we executing the task parallelly, we require only 1 unit of time. Many people have confusion over concurrency and parallelism. Even in many interviews, the question is asked, what is the difference between concurrency and parallelism? Both the terms stands for executing the task simultaneously. Then what is the meaning of concurrency and what is the meaning of parallelism, or what is the difference between concurrency and parallelism? A simple example I will give. Suppose we are talking and at the same time we are eating. So both the tasks we cannot do simultaneously. So what we will do? We will talk, then we will have a one bite, then again we will talk, then we will have another bite, then again we will talk, and then we will have another bite. So though we are doing different tasks, but one task we are doing, then we are stopping it, then we are switching to the another task, again we will switch to the another task, again we will do the another task. So doing both the tasks simultaneously, but giving some time for one task and then again switching to the another task and again switching back to the first task. This is called as a concurrency. While for parallelism, assume we are talking and at the same time we are walking. So we can talk at the same time we can walk also. So we are doing both the tasks simultaneously. So this is called a parallelism. So when we cannot do two tasks simultaneously, so we are switching from one task to the another task, but still it emit that we are doing both the tasks simultaneously. It is called as concurrency. While when multiple tasks we are doing simultaneously, then it is called as a parallelism. So in computer science, for example, when we have a single processor, so when we have to perform multiple tasks, what we will do? We will execute, the processor will execute for certain time. Suppose it will take 1 millisecond, then it will stop. The processor will execute this task for 1 millisecond, then again it will get stopped. Then this task will get executed for 1 millisecond, again it will get stopped, then this task will get executed for 1 millisecond, again it will come back to the first task, 1 millisecond, 1 millisecond, 1 millisecond, 1 millisecond. So single processor are doing this task, but this is called a round robin way. So it will perform this task, again it will get switch back to another task, it will perform some work, again it will switch back to the another task, likewise. So this is called as a concurrency. While for parallelism, instead of single processor, we can have the multiple cores. So one big processor, it has a multiple core. So one core is just like a processor only. So multiple cores we have, and we are allocating this task to this. So at the same time, this core is performing some task. At the same time, this core is also performing task. At the same time, this core is also performing task, and this core is performing task. This is called as parallelism, while this is called as the concurrency. Now we will discuss about need of parallel computing. Already we have talked, when we have the multiple tasks and we have a single processor, so it will take multiple time. So this task will take 1 unit time, then another task will take 1 unit time, then again it will take some time. So when we perform this task sequentially, so that much time it will take. But if we allocate the task to the different processor, so definitely it will take less time. So to increase throughput, we require parallel computing. For same example, if you have bigger task, so you can divide that bigger task into the subtask. This will be the subtask. So instead of performing this subtask sequentially, we can perform this subtask parallelly. So basically, it will increase throughput. We will see one example. Suppose we have to add two arrays. It has 5 elements, and again second array has 5 elements. Now suppose we want to add this, so there will be addition for this 2, then we have to add this 2, then we have to add this 2 and this 2. So generally for programming we apply for loop or any looping statement. So we will add this, then we will add this, then we will add this, then we will add this, and then we will add this. Suppose this addition take 1 unit of time, so for these 5 additions we will require 5 unit time. But if now these additions are not dependent on each other, addition of 1 and 2 is not dependent on addition of 2 and 4. Addition of 2 and 4 is not dependent on addition of 5 and 5. All these addition operations are independent. So instead of doing these operations sequentially, we will give this task to the one core. At the same time, we will give this task to the another core, this task to another core or processor. So having 5 operations will require only 1 unit time. Same example we can take for matrices addition. One more advantage of parallel computing is to use multi-core architecture. Nowadays, all the processors that we have are multi-core. For example, our i3, i5, i7, these processors are the 4 cores, while our processors in your mobile phones nowadays they are coming with octa-core, means 8 cores are there. So to use multi-core architecture of this processor, we can use parallel computing. There are some limitations of parallel computing. For example, though we have the multi-core architecture or multiple cores, still they are accessing same memory. So we have the same main memory. Now from main memory, this data instructions will be given to this processor. Now our processor, they have the higher frequency. So one study says your processor speed is getting increased by 40%, while our memory access time is getting reduced by 10% only. So in other words, we'll say that speed of memory is getting increased by 10% only. So though processor speed is getting increased by 40%, but memory access time or memory speed is getting increased by 10% only. So that is the one limitation. Another is when we have to perform big tasks, so we have to divide it into the small tasks. We will perform it parallelly, and again we will combine this result. So we will have the final output. Now to divide this task into the subtask and then to combine it, we call it communication cost. So So this communication cost, sometimes we call this as the overhead. It is more than executing the task sequentially. So this overhead is sometimes more than sequential cost. So these are the two limitations of parallel computing. Now we will discuss about applications of parallel computing. Parallel computing is used in various fields. For example, engineering and design, scientific applications, commercial applications, and our computer systems. If we talk about engineering and design, so it is used in mechanical engineering, where in internal combustion engine it is used for charging and burning at the same time. In civil engineering, for example, lift, where we are using for pushing and dragging. So in the same way, in electrical and electronics engineering, where it is used for high-speed circuits. So there are many applications are there. So we have listed some few. So in engineering and design, we are using parallel computing. In the same way, parallel computing is used in scientific application. So wherever there is a heavy computation, so we are using parallel computing. So big task is get divided into the smaller tasks and we are completing it parallelly. For example, astrophysics, here to study planet and stars. For weather prediction, for example, to study cyclones. Then in our medical science, so wherever there is a heavy computation, so we are using parallel computing. It is also used for commercial application. Better example is e-commerce websites. So we have Flipkart. So for Flipkart, sometimes we have Big Billion Days. For Amazon, we have Great Indian Sale. So many customers, they are putting requests to the server. Now to handle these many requests at the same time, it is difficult. So these requests are get distributed. They are given to the different cores, or they are divided into the subtasks, and all these requests are satisfied parallelly. In the same way, in our computer systems, this parallel computing is used. For example, you might be knowing about cryptography. We have various algorithms. For example, RSA and many algorithms are there. So it requires huge computation. So to reduce huge computation, we divide this computation we perform that huge computation parallelly by dividing into the small tasks. Also, it is also used for embedded system where various distributed algorithms are used. So for performing that various distributed algorithms, parallel computing is used. So these are the applications of parallel computing. It is used in engineering and design. It is used in scientific applications. It is used in commercial applications. It is also used in computer systems. So friends, I hope you like this video. If yes, then click on like, subscribe to this channel and don't forget to press bell icon so that you will get notifications of my next video. So stay connected. Thank you.